Bloomfield High, and welcome to Mr. Wood's awesome math class. Today we're going to be reviewing some test review problems and going over some various different things that maybe we struggled with a little bit on the recent test. Anyway, gotta like the minions though, just a little bit to lighten our mood as we get moving into some of these more challenging problems. So here we go. All right, so on the very first problem, we see I got a v to the minus 1/2 in the top and a v to the minus 1/2 in the bottom. So I can immediately go ahead and think about crossing those off. Now what do I see left? I just put the 1 there. I got a u squared there. I have a u to the minus 5/3. So I know I can go ahead and combine those. Well, when you combine those, it's like adding, right? So I'm just basically saying 2 plus negative 5/3, right? So this would be then 6 over 3 minus 5 over 3, which just gives me 1/3. So I have now u1 to the u to the 1/3, and then I have the v, which is the minus 3/2. Well, minus we know just moves up to the top. So when that moves up to the top, I just get v to the 3/2 over u to the 1/3, and that is our answer there. All right, for number 2, if I start kind of simplifying these down, so I got a 54, which I know can break down to 9 and 6. I know this is 3 and 3. I know this is 3 and 2. So I have 3 3s since we're looking at cube roots. So that becomes 3 cube root of 2, and that was a minus there. Well, I know this other one, so I got the minus 2 in the front. And so there's nothing I can do with that, so that's just going to drop down. So I got minus 2 cube root of 5. I can't break that down anymore. And then I have the plus 3 cube root 40. So I know I can break down the 40 to 4 and 10. I can do the 2 and 5, and I know this I can do as 2 and 2. So I got 3 2's. So if I have 3 2's, I can pull a 2 out, and I also have the 3. So that's going to give me the 6 cube root 5, and I'm just adding those together, right? So my final answer here is negative 3 cube root 2 plus 4 cube root 5. And there's the answer for number 2. All right, so for number 3, here I'm just going to look maybe greatest common factor. So I know I can pull a 2 and an n out, and that's going to leave me with 5n squared plus 7n plus 28. Well, if I tried to factor that any further to see does it really do anymore, so I'd have a 5n, and I'd have a set, so factors of 28. So if I tried all the factors of 28, well, so 1 and 28, 2 and 14, and 4 and 7, any of those that I tried would never add up to 7, right? Because I have to multiply this by some 5. So if I tried any number, well, that's a 10, and 10 plus something will never give me a 7. So there's no way to actually factor this out. So this one, the actual answer is just 2n, 5n squared plus 7n plus 28. That is as far as we factor out. I can see possibly I can pull out a 3 and an a, and that's going to leave me with a squared plus 2ab minus 80b squared. Right? So I'm going to ignore, so I'm going to leave the 3a out. I just want to factor this down. So I have an a here, I have an a here, and I know that factor, so I can do 80, so that would be then 8 and 10. So it has to be plus and minus, and put the b back in, and this is our answer. All right, so here for number 5, I already see that I have a common denominator piece here on the top. So I can go ahead and add those pieces together because the denominators are the same. All right, so I can make this x plus 4 over x plus 3. And then this is divided by 16 over x plus 3. And that means x plus 4 over x plus 3 times x plus 3 over 16. So those cancel out. And I'll just get x plus 4 over 16. And there's my final answer. Right? 6 is the same way. I was trying to give you guys some problems that I thought would be pretty easy for you. So 2 plus 4 over x squared is 6. We know that's 6 over x squared. And that says divided by half, which is just 6 over x squared times 2 over 1, which is just 12 over x squared. And there is number 6. All right, so for number 7, let's go ahead and just factor everything down that we possibly can before we do anything. And always remember, always think greatest common factor first. Is there anything that I can possibly pull out? Well, in the top part, I got a 50 and a 90, so I know I can pull out here a 10. I got a k squared and a k, so I can pull out a k. And that's going to leave me with 5 minus 9, 5k minus 9. On the bottom, I got the 2k minus 7, nothing I can pull out there. Over here on the other side, I never like to have negative letters. So instead of having negative letters, I'm going to go ahead and factor out the negative. And between 21 and 6, I can pull out a 3. Well, that's going to leave me, when I pull out, it's going to leave me with a negative 7 and a positive 2k. So for 30 and k, I can pull out the 6 and the k squared. And that's going to leave me with 5k minus 9. And now let's see, all right, well, I got a positive 2k, a positive 2k, so those cancel, those cancel. 5k minus 9 cancels 5k minus 9. And right now I'm left with 10k over 6k squared. Well, k over k, I'm left with k squared. And if I simplify the 10 and the 6, I can get 5 thirds. And I got a k in the bottom. And so that's our answer there for 7. All right, so here for problem 8. One thing, if I see equal, I want to find a way to be able to get rid of my denominators. So if I had the problem x, and I'm going to just go ahead and factor this out, x minus 6. So I'd like to find a way to be able to get rid of those denominators. Well, the way to do it is to multiply by our least common denominator. So what is our least common denominator? Well, it's this, right? So if I multiply that by x minus 6, x plus 2 over 1, what happens? Our denominator goes away and just get x minus. Same way here, if I multiply by the least common denominator, what happens? Denominator goes away, so I just get minus 2x. Well, over here, if I multiply by x minus 6, x plus 2, denominator goes away, and I'm just left with the 1 times the x plus 2. So now I got a real easy problem. This x minus 2x is negative x. Over here I have x plus 2. Subtract the x. So subtract the x, so I get minus 2x equals 2. And therefore, when I divide by negative 2, x equals negative 1. And we are done. All right, so for this problem here, once again, I have a denominator. I would like to be able to find a way to get rid of it. So, well, the denominators now cancel out. And so I just get n minus 6 equals 2n plus 5n plus 15. So now I can just combine like terms, 7n, right, n minus 6. So let's now move things around. So if I subtract the n to the other side, I get negative 6 equals 6n plus 15. Move this over, so I get 6n equals, so I'm subtracting the 15 equals negative 21. And divide by 6. So here I get n equals negative 21 over 6, which I can simplify by dividing both of them by 3. So I get negative 7 halves.